All right, we've been solving quadratic equations, and in past lessons you've been able to do that by finding the square roots and by factoring, and those methods are fantastic, but they don't always work. So we're going to try that by another method, by completing the square. And we can see what that looks like in this particular situation. So we're looking at x squared plus 8x. So here's my x, and there's 8 x's. I can play that out in a model. So here's the same expression rearranged in the form as a part of a square. Notice that the x tiles have been split evenly into the two groups of 4, so splitting up. So here's my x, and then here are 4, and here are my 4, my total of 8 x's. And when I complete the square, and that's what we're doing, I notice that there's these 16 extra. So I've got an x squared here, and I've got 1, 2, 3, 4, 5, 6, 7, 8. I've got an x squared, and I have an 8x, and then I've got 16 left over. What I've done is I've completed the square. And this term right here is my answer to the dimensions. So look at this piece here. This is an x, and then there's 4 here. So that is x plus 4. And then I've got an x and my 4 here, and this is x plus 4. So really this entire area can also be represented as x plus 4 squared. So that tells me that both of these are equal. And we can use this by completing the square. But here's another little formula to keep in mind. In general, you can change the expression x squared plus bx into a perfect square trinomial, which is what we want to do, by adding half of b squared to our equation x squared plus bx. So what it does is it gets us our c term. So we're trying to establish that c term, and in turn completing the square. We're looking for this piece right here when given my x squared and when given all my x's. What is that c term? And we can use this formula. Half of the b term squared does that. All right, let's practice that out a bit. Let's just see it happen. So let's first practice getting our c term, and then we'll practice using that to solve my quadratic equation. So I have x squared plus 16x plus c, and we're trying to get our c term. So, and remember my formula is I'm going to take b, I'm going to use half of it, and I'm going to square it. Now my b term is negative 16 as represented here. So let me substitute that in. So it's negative 16. I want half of that. And then I'm going to square it. And when I do that, I get 64. So to complete my square, I'm going to go ahead and I see my x squared minus 16x, and that is plus 64. Remember, that is also equal to, so like that's all the pieces of the area model that we saw in the last slide. But if we look at the dimensions of it, it is x minus 8 squared. It's 2 of those. And we can kind of see where we get that piece from. That x is here, squared, and then like 16 is half of that. All right, why don't you try it out? Try to find the c term for x squared plus 20x plus c. Press pause and see how you do. All right, in finding c term, I do half of b squared, which I find is 100. So x squared plus 20x plus 100 completes my square. And that's also equal to x plus 10 squared. And I can see where I get those pieces from. The x there, the 10 comes out of half of my 20. All right, now we're going to do it. Now we're going to use our c term to solve this, and I'm going to teach you how to do that. So solve x squared plus bx plus c equals 0. Okay, what are the solutions of this equation? And we're going to utilize what we know about perfect squares. So I'm going to take this. Now, in order for me to do this, I need to find a perfect square c term. So I'm actually going to subtract 16 from both sides. And what this brings me to is brings me to x squared minus 14x equals negative 16, because I am looking for a different c term right there. What I'm looking for is, I want to complete the square doing that. So I'm going to use my formula. I know that it's b half of b squared. So my b term is negative 14. So I'm going to do negative 14, half of it. I'm going to square that. So negative 14, half of it is negative 7. Negative 7 squared is going to be 49. And then what I do with that 49 is I'm actually finding out what I need to add to both sides. So I'm going to add 49 to my left side to give me my c term, but to keep the equation equivalent, I need to add it to both sides. So now my equation turns into this. X squared minus 14x plus 49 equals negative 16 plus 49. I can simplify that out a little bit, combine some like terms, and negative 16 plus 49 gets me to 33. All right, let's get some more room here. Now, remember, my right side is a perfect square, so I can see that it is x. So I'm going to be using this, minus 7 squared, and that equals 33. Now remember, I'm going to try to solve this. I want to get a solution to this. So I am going to square root both sides to 10 to my square here. And I end up with x minus 7 equals plus or minus the square root of 33. That's plus or minus because, remember, anything negative times a negative is going to get me to a positive. So I'm going to include both answers on this one. Square root of 33 is about 5.74. Okay. Well, now I'm going to look at my two parts here because I know that x minus 7 is going to equal 5.74, and x minus 7 could also equal negative 5.74. I don't know which one it's using. I don't know if it's using the positive version or the negative version of it. So I need to consider both of them. So that's why I've got my or here. I'm going to add 7. I'm going to add 7. And I end up with x is about 12.74, or x is about 1.26. And those are my two x-intercepts. Those are my two solutions to my original equation. A lot of steps involved here, but we're just finding another method to solving a quadratic equation. All right, I want you to give it a try. If you need to look back at some of the notes, please do that. But once you press pause and you try it on this one. All right, a lot of math spilled out here, but I tried to find my c term of my perfect square, and I found 20.25. I used that to find x plus 4.5 squared. I square rooted 5.25, and again, it's a plus and minus, so that's where I was able to get my terms in red here, my two equations, x plus 4.5 equals 2.29, or x plus 4.5 equals negative 2.29. I simplified those and found out that x is going to be negative 2.21 or negative 6.79. Now 6.79 is smaller, so I want to put that first, so negative 6.79 or negative 2.21 would be my final answer. Now where I was looking for how to use more things, but you can also use the equation in this perspective if you want to use your perfect square to find the vertex of a quadratic function. Okay, so let's use this equation, y equals x squared plus 6x plus 8, and complete the square and then use that to find the vertex. So let's go ahead and do that. Up here, we're going to keep an eye on these pieces here. So we're basically trying to turn this into this. And then once we knew k and h, we now have the coordinates of our vertex. So let's try it out. try this. Y equals x squared plus 6x plus 8. And remember, I'm going to subtract 8 from both sides because I want to get to that perfect square. So I end up with x squared plus 6x equals, I threw the y on the other side, y minus 8. I just flip-flopped the two. I don't know why. I'm just going to keep going here. All right, so now that I have these pieces here, I need to add. Okay, and I'm going to add my b term in half squared, and my b term is 6. So I'm going to take half of 6, and I'm going to square that, and that's going to get me to 9. And so I'm going to add 9 to both sides, and that gets me x squared plus 6x plus 9, and it gets me to y plus 1. Then I'm going to subtract 1 from both sides, and that, oh, no, I need to get my perfect squares first. I don't want to muddle this up. Why I stopped there is because I know that this is a perfect square. I just did all that work to get the 9, and that allows me, if I subtract 1 from both sides, that's going to turn to an 8, and is no longer a perfect square. That would be silly. I know that this side, this is a perfect square. It's x plus 3 squared. That I know. Now, I'm going to subtract 1 from both sides, and I can get my x plus 3 squared minus 1 equals y. All right, find the vertex of this by completing the square. So now that we've completed the square, we can actually see, remember from our original equation, if we get it to look like this, get it to our perfect square, and then a k term, we actually have found our coordinates. Our coordinates are right here. Remember, because it's x plus 3, we have to zero out to find our x-intercept. Our first coordinate is -3, and our second coordinate is -1 as we see it. So you'll use the k term as you see it, but the h term, you need to keep in mind that you are equaling that out to 0 to find the x coordinate. Okay, so we'd be using x plus 3 equals 0 minus 3 from both sides. So that's where we get to our negative number for that one. All right, why don't you go ahead and try it out on these two problems. Press pause and come back and see how you did, and go back and check the notes as well. All right, take a look and see how you did. Check the details of this. Remember, I was ultimately took up my original C term and put it on the other side of the equation so that I can find the perfect square C term. And then I simplify it out, use the bottom, and ultimately what this was doing is this was helping me find the vertex of my parabola, which was the solution I was looking for in this case. It's going to take some practice, getting all the details and keeping track of everything. All right, I'm going to go and shave the shape of a panda on the side of my head.